the actual EVs and the potential of electrifying our fleet.
Okay, thanks. Am I talking loud enough? Chris Jones, head of the EVA here, the local chapter, was going to do a talk, but since he's been racing electric motorcycles over east, I'm standing in for him as well as throwing in some knowledge of ours from seeing his calculations.
And winning.
Yes, good. Anyway, so this coverage, this film we saw covered a lot of what I was going to say here about the benefits of electric vehicles. I think everybody knows most of this stuff here. But the first thing that a lot of people want to know about, of course, is the costs. And so I've tried to anticipate some of those. For example, what does it cost to drive? And basically, if you do rough calcs, it's and experience of those people, including myself, driving, it's about a quarter to a third of the cost of petrol. So when you add that to maintenance, which is much lower, as the movie well covered, you rack up quite a bit of savings. And I calculated when I did my electric conversion that I was going to save roughly $10,000 over 10 years, but I only drive about half the Australian average. So if you drive an Australian average, you roughly save, I'll figure about that over say 6 years. So of course, if you're going to compare apples and apples when you go to buy an electric vehicle, you need to look at the operating cost of the system over a period of time that you're expecting to own it. So that's just what I worked on. Tesla, this is an interesting graph here. Tesla's price per kilowatt hour of electricity, of the energy storage in their batteries, and the other car makers here. The next question is usually how far can I go? And most of the common cars around, we've got a lot of Leaf and Mitsubishi Pontiac owners here in the audience. They're in the range of 100 to 160 kilometers, depending on how you drive. And of course, the same thing with petrol, depending on how you drive and your range perspective. Tesla's got a range of 500 kilometers with the S version, and even the little Roadster was 450. And this graph here just illustrates the typical daily driving distance for most people is easily covered by a 100-kilometer range. The next thing, of course, is how fast can you charge it when you need to. And one of the experiences I think most people are finding who drive in this, you don't necessarily have to, you don't drive the car till it's fully discharged. You drive it and then you top it up and next get a charge. So often, these periods of time for charging a typical, say, 24 kilowatt hour pack might be, off the standard wall socket for about 10 hours. The 24 kilowatt hour, the stage 2 charge rate, 3.5 hours and 30 minutes for a full charge. If you can do that, usually you only charge 80% in a very short time. That is, it's not that important. It's only if you're going long distances. So. And the next question is, where can you charge in Perth? And there's a whole bunch of places. City of Perth Parking, Fremantle, and a number of other ones here. And this is just, if you do a search on PlugShare Perth, this is what you come up with, and you can zoom in. There's many more stations than what you see here. Shows different rates of charge if you can get one. The other thing that I was asked to talk about was how does this how does this charging affect our electricity grid? So, is it going to crash our system if we all come in and plug in at, say, 6 o'clock in the evening? And the answer is potentially, as we get more and more, yes, we can. But if the answer really to avoiding that is to look at the way we use energy through the day, say 24-hour period. This is a typical profile of energy demand. And you can see there's large areas here that are not used. So if we charge that fleet at those times of the day, and that's all programmable and things like that, then we can avoid them. So time of use tariffs on electricity would encourage people to charge off of the peak costs in the peak demand period. Also, the electric vehicles can supply what's called ancillary services. So it's essentially, if you have a fleet of cars plugged in, thousands of cars plugged into the grid, on charge, they can be doing two things. They can be doing two things. They can either be putting, taking charge out of the grid, but that can be modulated. That speed of charge can be, that rate of charge can be modulated to balance other loads in the system. So by balancing, offsetting other changes in the system, you can provide both voltage and frequency support and stabilization. And you also have a huge battery effectively all plugged in at the same time. This is just a credit to the Electric Vehicle Association, but in particular Chris Jones, who pushed the electric highway concept with, I think, one of the other EVA members, but he's been pushing it with the RAC in particular, and they've agreed to instate electric highways plan here. Supposedly this is planned to be installed by this time next year, so you'll be able to take an electric car and drive all around the Southwest here with minimal. And I believe all of the energy is going to be renewable or sourced from renewables. A few other questions, of course, always come up. Lithium batteries, how good are they for the environment? They are all recyclable. They're not considered hazardous. There are recycling plans by Nissan and Tesla. I'm not sure how far along it is, but if you look at the new Tesla Gigafactory website, you can see that it's integrated into their production system. The lithium resources, the U.S. Department of Energy and the University of Michigan and Ford have looked at that, and they tend to think that it's sufficiency into the century. I presume they factored in the growth of electric vehicles and so on. Relative greenhouse emissions, just really quickly, this is a typical petrol car. These two colors, petrol upstream and petrol at the tailpipe, this is the processing, everything to get the petrol to you. This is what you actually burn in the car. So for these are typical internal combustion engine normal. This is a hybrid, plug-in, those are hybrids. And then these are electric vehicles being charged off of the electricity grid that uses fossil fuels. But of course, if you look at if you go green power, 100% renewable, your emissions are essentially zero. Pretty obvious, but you see. The societal benefits, of course, we all know pollution. Here's a regular internal combustion engine car, Euro 4. If you're charging an EV off the electricity grid, it's those kind of particular matters, and greenhouse emissions and so on. And of course, again, if you go green power, it's nothing or very little. These are the reference websites. I got the information. So, and, I don't know. I'll talk to you later.